Alright, for this video I'm going to be talking about the effects of temperature on catechol oxidase. This is written by me, and we'll just start right off with the overall purpose of this experiment, which is just to show how much temperature affects the ability of an enzyme to function properly. And as you can see in the picture in the middle, it shows an enzyme before denaturing where it is able to properly function and is of a correct shape that can accept things of the shape A, B, or C. But after denaturation, it cannot do that, and that is can be affected in many different ways, such as acidity or basicness of substance, but also by hot or cold. And that is obviously what we're going to be talking about today. And so to start off, obviously we need to ask, what are enzymes? And enzymes are essentially little factories in the body, or more less factories and more tools that can be used to create many of the building blocks that our body depends on. And to do that, they can either take something called the substrate and separate it into two different pieces called products, or take two different substrates and seal them together to make a different product. And those products can be many, many different things with many, many different kinds of enzymes for many, many different kinds of jobs, and they serve many, many functions in our bodies. And today we're going to talk about a specific enzyme called catechol oxidase. And when we're talking about catechol oxidase, we're generally going to be talking about the problem it faces with denaturing. And to denature a protein is to modify the bonds that link it together. And so we can see that in this image here, where it starts off in its proper shape with all the bonds correct, but as it begins to deteriorate in its condition, it changes its shape and it loses the proper bonds that hold it together, which causes a lot of damage to its ability to actually function in the body. To a certain point around here, it could still be used to some certain extent, but when we get to this area, the bonds are completely broken apart and is totally unable to do its thing. Because as I said earlier, it's kind of like a little factor in the body, in that it is a very delicate thing that needs to be carefully dealt with, and all the parts need to be in proper place, or it really won't be able to work at its maximum potential or even at all. And so how does temperature tie into that idea of denaturing? Well, as we can see from this, temperatures, whether or not they're very high or very low, can often affect the way an enzyme works in a situation. So here we have, this is for catechol. This is just for enzymes in general. We've got an optimum temperature normally in the middle. Well, when it's very cold, it generally still retains some form of function, but incredibly decreased. And when very hot, that causes what we talked about earlier with the denaturization, totally breaking apart the bonds and leaving it with almost no ability to function whatsoever. And so that leads us to our main hypothesis. What is going to happen if catechol oxidase is exposed to extreme temperatures? And the hypothesis that I've come up with is that if catechol oxidase is exposed to extremely high or extremely low temperatures, then it's going to denature and it's not going to be able to properly perform its function in the body. Or not in the body, but in the plants that it inhabits and is used by. And so the process that I chose and for which to prove that, so the experiment has you using 3 different samples of catechol oxidase in vials, one of which is to be taken and just left at its normal optimal temperature to be used as a control, one of which is to be submerged in an ice bath to be used as generally a show of how when it's cold. This ice bath will generally be around 0 to 5 degrees Celsius for that. And the last sample will be placed in an oven at around 75 degrees Celsius to show what will happen when the catechol is heated to that higher temperature. And then these 3 samples will be collected and catechol will be placed in each one, so that afterwards we can check how much of the product that catechol oxidase produces after consuming catechol remains there. And we can tell by that exactly how much the catechol oxidase has retained its ability to function. And the outcome of that is that we can see that exactly kind of what we predicted did happen, where when it got much colder, it didn't quite stop its function, but it did become much less efficient at it. When it was at its optimum temperature, it retained its pretty much full ability to function. But when it got very hot, around that 60 to 75 degrees Celsius margin, it completely lost its ability to function at this area, where that shows that it's obviously completely broken down. and would never at that point be able to return back to a functional state, as all the bonds have been broken by the heat. And so, in conclusion, the general purpose of this experiment was just to show that when you have incredibly important enzymes, they can be damaged quite harshly by temperature or acidity or basicness or whatever you may have. And especially in this case, the high temperature could completely destroy the enzyme and remove its ability to work. So I'd say if there's anything to take away, it's that when we're working with things like enzymes, it's very important to take into consideration the temperature, as that can greatly affect how much that enzyme is going to be able to function in its proper place. And with that, I'm going to be ending the video.